In this video lesson, we're going to explore complex ions. So complex ions are formed when ligands bond with central metal ion. And ligands are molecules or ions that have lone pairs of electrons, either one or more. And the ligand will act as a Lewis base, and the metal ion will act as a Lewis acid. And the metal ion will accept the lone pairs of electrons from the ligand, and which will form a coordinate covalent bond. So ligands can be neutral molecules with lone pairs of electrons, or they can be charged ions. All ligands must have lone pairs of electrons to donate, which will make them the Lewis base. Most ligands, like water and ammonia, will share one pair of electrons, and that will make them monodentate or one-tooth ligands. Ligands that share two pairs of electrons are bidentate ligands, and ones that share multiple pairs of electrons are polydentate. And we'll look at each of these as examples. So water acts as a monodentate ligand. So in copper 2 sulfate solution, the copper 2 plus ions form a complex ion with 6 water molecules. So here they are. And each of these water molecules are sharing one pair of electrons with the copper 2 plus, and that forms a hexa aqua copper 2 ion. And it's represented as follows. So we write in square brackets, we'll talk more about this in another example. Square brackets, the copper, and then in parentheses, the water, subscript 6, square bracket 2 plus. So you can see that we have our copper, we have 6 water molecules, and then overall, the whole thing has a +2 charge. A bidentate complex ion involves 2 pairs of electrons being shared each time. So in this example, cobalt, which also is a 2 plus ion, forms a complex with a bidentate ligand called ethane 1,2-diamine, or for short En. So each of these has 2 pairs of electrons. So there's ethane here, and then there's 2 amino groups on either side, and each of those are sharing 2 pairs of electrons, and there's 3 of them. So the notation would be cobalt brackets En subscript 3 larger bracket square brackets 2 plus. So the overall thing still carries a 2 plus charge. A polydentate ion has many pairs of electrons to share, and in this example, zinc 2 plus forms 6 coordinate covalent bonds with EDTA 4 minus, which is a hexadentate ligand. The coordination number for a complex ion tells you the number of coordinate covalent bonds that are being formed. So if you take a look at the hydrated copper 2 plus ion from the first example, the coordination number is 6 because each copper 2 plus shares with 6 water molecules, and each of those water molecules is donating 1 electron pair. So the coordination number is 6. But the coordination number would also be 6 for the next example with cobalt binding with the En. It binds with 3 of them, but because each of them has 2 pairs of electrons to be shared, there's a total of 6 pairs of electrons being shared. So it's still a coordination number of 6. So table 1 from our Cognitive textbook shares some common ligands and their coordination numbers, and then their shapes of the complex. So when the coordination number is 6, the shape of the complex is octahedral. If it's 4, it can be tetrahedral or square planar. So when we're writing complex ions, we place square brackets around the whole complex. The overall charge is written outside of those square brackets as a superscript. And then from this information, you can then determine the coordination number and the shape of the complex ion. So in our first example, we have silver forming a complex ion with 2 ammonia. So the way we would write that is the following. So we would put square brackets and write Ag, and then in parentheses the ligand, which is NH3, and there's 2 of them. And then there's an overall 1 plus charge. So this time the shape is linear because there's just the 2 pairs of electrons being shared by 2 different ligands. So it's linear. And our coordination number is 2. Because there are 2 pairs of electrons involved overall. Our next example is a copper ion with 4 chloride ions and a -2 charge overall. So this time we're going to write Cu and then Cl, and there's 4 of them, -2 or 2 minus. So this time the shape is tetrahedral. And our coordination number is 4. Because there's 4 pairs of electrons involved. So in this next example, we have 2 different ligands being involved. So this is going to change the shape slightly just because of the nature of the 2 ligands. So instead of being tetrahedral, it will be square planar. So this time we write the ion as nickel, and then we have 1 ligand that's ammonia, and there's 2 of those, and then we have another ligand that's chloride, and there's 2 of those, and there is no overall charge. The shape is square planar. And our coordination number is 4. So we'll write the next example. So we have iron with 6 cyanides and overall 3 minus charge. The coordination number is 6, and the shape is octahedral. So coordination compounds are when those complex ions will form ionic bonds with counterions that will balance out the charge on that complex ion. So this example here that we have will be the hydrated iron forming a coordination compound with 3 chloride ions to balance out that overall positive charge that was on the complex ion.